So in chapter 5, these first couple sections, we are looking at making new functions from existing functions. So adding two functions together to make a new function, subtracting them, multiplying, and so on. And this particular example shows us how we can take the profit function for a company and create it using the company's cost function. So cost is money going out, and the revenue function, revenue is money coming in. It's a pretty classic example for profit. So in these examples, the first thing you'll be doing is evaluating, interpreting. You might be doing the function combining, like in here, give the profit function, which will be a combination function. But then also trying to figure out what's going on at the zeros. So what happens when x is 0, what happens when the function value, the cost is 0, or the revenue is 0, and so on. So zeros are a pretty common thing that we look at with these applications of these functions. So for part A, it says to evaluate and interpret C of 5. If you haven't read the problem, take a minute now and pause the video and do that. So C is the cost function, and it says that it's in thousands of dollars. So when we do our interpretation, we'll want to make sure that we talk about the output being in thousands of dollars, and X is the number of sailboats. So when it says C of 5, remember the 5 is an X value, an input value. So when I interpret this, I'll talk about what happens when I have 5 sailboats that I'm producing. To evaluate C of 5, I'll do that first and then I'll interpret it. To evaluate C of 5, it means to plug 5 into our cost function, right? And then evaluate it. So when I evaluate this, I get 10 plus 20 with an output of 30. To interpret this, I would talk about the 5 being a number of sailboats and the 30 being the thousands of dollars of cost. So when 5 sailboats are produced, the cost is $30,000 since the output is in thousands. All right, for part B, it says interpret the y-intercepts on the graphs of C and R. So you do not actually have to graph this. For a y-intercept, you just have to remember that you're looking at the place where the x value is 0, right? A y-intercept on a graph, for instance, a linear graph, is where the graph crosses the y-axis, and it always crosses at a place where x is 0. And so what we're looking at for part B here is really just interpreting C of 0 and R of 0 when no sailboats are produced. Essentially, this would be like an initial cost, a setup cost, and then some sort of initial revenue, which theoretically be 0 because you only really make revenue when you sell things. So for C of 0, if I plug a 0 into the cost function, 2 times 0 plus 20, it looks like I have an initial cost of $20,000. This would be something like a setup cost, setting up your factory or buying your preliminary materials. For R of 0, 4 times 0 equals 0. Which makes sense because we should have 0 revenue when we've produced and sold 0 product. So to interpret that, just something to the effect of initially there is a cost of $20,000 and $0 in revenue. Initially meaning when you've produced 0 product. All right, for part C, to give the profit function, first of all, profit. So profit is your net money that you make or lose as a company. So you always start with the money that you take in, and you subtract the cost, and the net of those two, the difference, is your profit. When the revenue is higher than your cost, that's when you have positive profit, but when your cost is higher than your revenue, you have negative profit. You've lost money. All right, so for this, the first thing you'll do is just subtract the revenue function minus the cost function. Okay, so notice that I have the revenue function 4x, and when I subtract the cost function, notice that I'm putting it in parentheses. I need to subtract this entire function, which means I'm subtracting each term. That negative will distribute. This is the most common mistake that people make when they are subtracting these polynomial expressions, is not distributing that negative to every term in the polynomial you're subtracting from the first. So for the profit function, I've got a 4x minus a 2x minus a 20, which simplifies to be 2x minus 20. This is making a new function from an old function. This describes the profit when we make X sailboats. So this is the net gain or loss when we take into account both the revenue and the cost. From there, you could evaluate the profit at certain numbers of sailboats sold. So you could plug in 5 and see, okay, we knew the revenue was $30,000, but what's the profit? How much of that do we get to keep? This particular problem asks how many boats need to be sold for us to break even. Break even means that your revenue and your cost are equal to each other. If your money going in is the same as your money going out, you break even, you have a 0 profit. So you can either set this up by setting your revenue and cost equations equal to each other, or the same thing would be if you set your profit function equal to 0. If your revenue and cost are equal to each other, then your profit would be 0. That's a little bit easier just because we just made the profit function, but really either of these methods is okay for break even. So I'm going to go ahead and do my profit function, 2x minus 20 equals 0, and then I just solve it. So I'm skipping those steps there. It's pretty straightforward. And I get an x value of 10. This would be the same thing you would get if you set your revenue and cost functions equal to each other. And what it means is that we break even if we sell 10 sailboats. Nice, that's a solution. So that's revenue function. Revenue is a pretty classic example of function combination. And if you are a business major, then you'll definitely see that a lot as you go into business math and business calculus. All right, the next example, I'm going to slide down, don't get dizzy. Section 5.2, but I'm going to do a little bit more of that function addition and some function evaluation here. We've got 2 functions, and we're talking about combining them using multiplication. So when you see this little f and g in parentheses together, it means you're multiplying the f function and the g function. Yeah. This means we'll be evaluating it at 2. When you see the plus sign in parentheses, it means you're adding the functions together. Okay. But when you see the plus sign over here, then that's part of your input. So you're going to use a sum as the input. So kind of watch what I do when I go through these examples and notice what's different about how each of these are solved. Okay, so for the first one, it says find f times g of 2. So you have 2 options here. You can either first find the new function that we get by multiplying the f function and the g function, so f of x times g of x. But because we just are interested in finding the value of this function at 2, you might just jump straight to evaluating each of these functions at 2, so f of 2 and g of 2, and then multiplying those results together. These would be specific y values. So that's what I'm going to do here. So f of 2, remember f is the name of the function, so it means here's f. We'll find the function that's labeled f, and that's where you'll plug your input of 2 into. So f of 2 would be 2 squared minus 4 times 2. I use 2 in place of x in my f function. And then I just solve. So 4 minus 8, negative 4. And then I've got g of 2. So for g of 2, it's telling me go find the function g and use 2 as your x value, as your input. So everywhere I see an x, which is just in that one location for this one, I'll plug in a 2. 2 squared minus 5 would be 4 minus 5, or negative 1. So then f times g, evaluated at 2, is the same as f of 2 times g of 2, which is the same as negative 4 times negative 1, positive 4. All right, I'm going to scroll up here a little bit. All right, so when I want to find f plus g of x, this is the same thing as finding f of x plus g of x. They're saying, let's find a new function, f plus g, but they're telling us how to find it by adding together these functions that we already have definitions for. So to find this new function, and we don't need to evaluate it, we're just going to find the expression since there's an x here. I'm going to just add the expressions together. X squared minus 4x, that's f of x, plus x squared minus 5. That's g of x. And then since it's addition, I'm just talking about combining like terms here. X squared plus x squared is 2x squareds, negative 4x, and minus 5. So this is a new function, and we name it f plus g since that's how we found it, by adding the functions f and g together. All right, the last example for this section is, I think, the most challenging for students, f of x plus h. You've seen examples of things like f of a plus 2 or a plus 3, and for some reason it throws people off to see the x plus h. The reason it's included in this section and in this course is that it comes into play again in algebra, and especially if you're going on past algebra to calculus, you'll see things called difference quotients, where all you do for the whole class is do things like f of x plus h and use it in application. So it's a really important application as you move on past this particular course. All we do here is just evaluate it. And it works the same way as what we did over here when we plugged 2 into our f function, except we're going to plug x plus h into our f function. So that means everywhere we see an x value in input, so it was x squared minus 4x, right? So these are the places where there were x's. Now you're just going to put in an x plus h. So it's an input value. It just gets put in place of x in your function. I think that's the hardest part. From there, it's a matter of evaluating. So the next trickiest part is that when you square x plus h, you want to be careful. Squaring something means multiplying it by itself. X plus h times x plus h. So don't just square the x and the h. There's more going on here. I'll leave this guy alone for just a minute. Slide over. So to do x plus h times x plus h, you might remember foiling. You might call this just distribution, but you want to multiply each of the terms in your first polynomial times each of the terms in your second polynomial. 2 terms times 2 terms should get you 4 terms before you combine any like terms. So x times x is x squared. X times h is hx. And then we distribute the h. H times x, there's another hx, and h times h squared. I'm running out of room, but I still have this minus 4 times x plus h, which is a minus 4x minus a 4h. The negative gets distributed along with the 4. So from there, I'm looking at just combining any like terms, and it looks like all I've got is this hx term to combine. And so it looks like f of x plus h. So my function f evaluated at an input of x plus h is equal to the expression x squared plus 2hx's plus h squared minus